There are two main different methods of adding mixed numbers. Firstly, before we do either of them, we need to actually understand what a mixed number is. So if you look in the box at the bottom here, I've written that mixed numbers are those that have a whole number and a fraction. So in this example, I've written 1.5, where the whole number is 1 and the fraction is a half. So if you look at the left-hand side where I've written question 1 under method 1, our whole numbers are the 2 and the 1, and then we've got our fractions, so 3/4 and 1/3. So for this method, lots of people like to add the whole numbers first. So lots of people would take the 2 and they'd take the 1 and they'd add those up first. So 2 add 1 makes your 3. Now, then it becomes a little bit trickier because we've now got the actual fractions there. So we've got ourselves 3/4 add 1/3. In a previous video on adding fractions, I went through the method of this, but the main thing to think about is finding a common denominator. So the denominator is the number underneath the fraction line. So in this case, we've got a 4 and a 3. And to find a common denominator, we need to think what number is in both the 4 times table and the 3 times table. In this case, it's 12. So I'm going to try to find the equivalent fractions of both 3/4 and 1/3, where 12 is our denominator. So first let's look at our 4 and we think, what do we do to that 4 to get it to 12? Well, you multiply it by 3. With all fractions like this, when finding an equivalent, if you do something to the denominator, you must do it to the numerator as well. So we must multiply our numerator also by 3, which leaves us with 9/12. Now let's look at the 1/3. And you think, what do we do to that 3, the denominator, to get that into a 12? Well, you multiply it by 4. And just like in the first fraction there, we do the same to the denominator as we do to the numerator. So the numerator must also be multiplied by 4, which leaves us with, and I'll just rewrite it underneath, 3 plus 9/12 plus 4/12. And I'm actually going to write the 9 plus 4 on top of the fraction line and just leave the denominator as 12 underneath. That's because when adding fractions, once the denominator is the same, you just add your numerators. So that leaves us with 3 and 13/12. But that looks really awkward. You can't have a whole number as being the 3 and then an improper fraction, which is the 13/12. So that, we need to rethink this bit. So I'm going to keep our 3 as being the same, but then our 13/12, we need to turn that into an improper fraction. So that's asking how many 12s go into 13. Well, 1/12 goes into 13, and there's 1 left over. So that leftover, or that remainder, goes as a numerator on top of the denominator, which is 12. But we're still not done, because we've still got our 3 as our whole number, plus our 1 and 1/12, which leaves us with 4 and 1/12. Now, the reason I went through that method is because I know lots of people like the idea of adding the whole numbers up. However, personally, I think method 2 is better. It works better for me, as I think there's less steps. So I want you to really focus on this one. However, obviously, if you find method 1 easier, then go with that. So for method 2, instead of adding up the whole numbers, you have to first turn your numbers into improper fractions. So for question 2, I'm going to write the question as 1 7/8 plus 2 1/2. So instead of adding the whole numbers 1 and 2, instead we're going to look at 1 7/8 and we're going to think, how can I turn that into an improper fraction or a top-heavy fraction? Well, 1 is the same as saying 8/8. And then we've got 7/8 as well. So we've got 8/8 plus 7/8, which makes 15/8. So that is what 1 7/8 turns into. Then 2 1/2, we think, how many halves are in 2 wholes? Well, four halves are in 2 wholes, And then we've got 1 left over again, which leaves us with 5 halves. Now, just like with all adding fractions, even if it was a normal fraction that wasn't improper, you have to still find the common denominator. So what number is in both the 8 times table and the 2 times table? In this case, it's 8. So I'm going to write 8 as my denominator for both. And then I need to think, okay, is there anything I need to do to those numerators? Well, luckily enough for our first one, 15 over 8, it's already in 8s. So that can stay exactly the same. However, for our second fraction, you need to think, what do we times or multiply 2 by to get to 8? Well, we multiply it by 4. And because we've done that to the denominator, we must do the same to our numerator. So we must multiply 5 by 4 as well, which leaves us with 20. Now, these numbers look a little bit awkward, but you'll soon see that why I think it's easier. So then we add our numerators and we keep our denominators the same. So 15 add 20 is 35, and our denominator stays at 8. Now this is just now asking, it's like saying how many 8s go into 35. That fraction line is just the same as saying divide. So 8, we know that 8 times by 4 makes 32. So that then becomes our big number. And then what's left over, our remainder, to get to 35 is 3. So that stays as our numerator, and our denominator stays the same as 8. So as I said earlier, personally, I like method 2 better, but if you find method 1 easier, that's absolutely fine.